So welcome to module number 19 in Unit 4, Sensation and Perception. And remember, we're following along in Myers Psychology for the AP course, 3rd edition. And as I said, we're on module 19 at this point, talking a lot about sensation and perception. This is a really interesting module with many cool visual things to really think about and process. And I would like to take this moment, if you are listening, to please consider subscribing to my YouTube channel. I do hope to get all 80 of the main modules for Myers Psychology for the AP course 3rd edition onto my YouTube channel by the end of this academic year, so by May 2020. So the learning targets, this is somewhat of a long module, but it is really, really interesting. The learning targets for this module include describing the Gestalt psychologist's understanding of perceptual organization and explaining how figure, ground, and grouping contribute to our perceptions. Also, understanding a bit about binocular and monocular cues and how we use them to perceive the world in 3 dimensions, and how we understand and perceive motion. We also are going to be learning about how perceptual constancies help us construct meaningful perceptions. And finally, we're going to be looking at research on restored vision, sensory restriction, what happens when you restrict some of your senses, and perceptual adaptation, and what this reveals about the effects of experience on perception. So the Gestalt psychologists were really interesting German psychologists who had some fascinating ideas about understanding that there was a big difference between looking at something as a whole versus looking at its parts. And they really felt like the whole was different than the sum of its parts. So they said they believed that in perception, the whole may exceed the sum of its parts. So it isn't just that you're seeing the parts put together. The whole is something wholly different. So what it says here, early in the 20th century, a group of German psychologists noticed that people who are given a cluster of sensations tend to organize them into a gestalt. The gestalt word means whole. So underlying these Gestalt principles is sort of a fundamental truth. And this is, we're thinking about how is perception understood by the Gestaltists, a very German sounding word. Our brain does more than register information about the world. So our sensory system is bringing information in through those sensory channels, but our brain does more with it. Our perception is more than what is just coming in with through the senses. Perception is not just opening a shutter and letting a picture print itself on the brain. We filter incoming information and construct our perceptions. That's what's so important to see there. We aren't seeing things completely as they are. Our brain, our mind, is constructing our perceptions. And if you guys had any experience with the dress that people saw in different colors, or the names, what were they? I'm totally Yanni and Laurel. Like we definitely perceive things differently than other people, and our brain constructs what we are actually perceiving. And those were 2 good examples that sort of caught people off guard about, whoa, wait, everyone's not seeing or hearing the exact same thing. And they sort of gave us a window into how our perceptions can be very different. So this is a really interesting idea within Gestalt psychology, the Necker cube. And how does the Necker cube illustrate Gestalt? So if you look at it, the individual elements of this figure, the Necker cube, are really nothing but 8 blue circles, each containing 3 converging white lines, right? If you look at each of those, that's all that is. It's 3 circles with white lines in it. However, when we view them all together in the position that they're in, we see a cube that sometimes reverses in direction, like which parts of the cube you're seeing in the front and which parts of the cube you're seeing in the back. So there's actually no cube there at all. Our brain is just perceiving that cube. Our brain constructed that cube. So as for an AP exam tip, for those of you who are planning on taking the AP exam, The Necker cube is really an excellent vehicle for understanding the distinction between sensation, what our brain is bringing in through our senses, and perception, what our brain actually perceives, what isn't even there. The only visual stimuli are those blue wedges. That's the sensation that's there. That's what's coming in through our senses, our visual sense. The circles, lines, and cubes are all products of your mind. They're not actually there. Go back and think about that. There's no cube actually there. We're only seeing a cube because our brain is perceiving a cube. That is perception, and just absolutely fascinating. So what is figure ground? Another concept within Gestalt psychology. You may have seen this. If you look at this picture to the right, are you seeing a vase? Are you seeing two faces? Is it switching back and forth? The organization of the visual field into objects, the figures that stand out from their surroundings. So can you detect figure and ground? See if you can actually reverse the figure and make it ground. Now, vice versa. So it's your choice. Like, I can look at it and I can see the vase and I can see the faces and I can see the vase and I can see the faces. And it's just interesting, right? Like, our brain is sort of perceiving different things depending on where we're putting our focus. So what would you answer? Brianna and Charles are doing a dance, are in a dancing competition. It's easy for spectators to see them against the dance floor because of E, figure-ground relationships. So how did the Gestaltists apply rules for grouping? This is really important, this concept of grouping within perception. Our mind, again, different than what our senses are necessarily seeing, our mind brings order and form to stimuli by following certain rules for grouping. These were also identified by the Gestalt psychologists. These rules, which we apply even as infants, even in our touch perceptions, illustrate how the perceived whole, the Gestalt, differs from the sum of its parts. Rather, this is a really great example to think about it, right? Most of us, and probably all of you, know that water is made of H2O, right? 2 hydrogens and 1 oxygen. But the sum of the parts is extraordinarily different from the parts itself, right? Water is fundamentally different than hydrogen and oxygen by themselves. So that's a good analogy to think about in terms of Gestalt psychology. So one of the grouping principles is proximity. It's a Gestalt law of grouping that states we group nearby figures together. So when we look at this picture to the right, we don't see 6 separate lines, but we see 3 sets of 2 lines, right? We see 3 groups. And really, there are 6 lines there, but our brain automatically goes to seeing 3 groups. So another concept of grouping in Gestalt law is continuity. We perceive smooth, continuous patterns rather than discontinuous ones. This pattern could be a series of alternating semicircles if you really look at it, right? It's just semicircle, semicircle on the bottom, semicircle on the top, semicircle on the bottom, semicircle on the top. But our brains perceive it as 2 continuous lines, one wavy and the other one straight. And that is the principle of continuity. Closure is a law of grouping that states we fill in gaps to create a complete whole picture, right? This is a really interesting one. We assume that the circles on the left are complete but partially blocked by the illusory triangle. Add nothing more than little line segments to close off the circles, and your brain stops constructing the triangle. So this is the principle of closure. So try this. How can this be happening? Look at this picture. If you really look at it, it looks crazy. It looks impossible. It doesn't seem like it's possible, right? As that guy is kind of pointing out with his, quizzical look there, right? So this doghouse is impossible. From the photo angle in the try it picture, the Gestalt grouping principle of closure leads us to perceive the boards as continuous. But really, if we go back, they're not. So what is depth perception and how have we tested for it? Depth perception, and some of us might think we're really good at having depth perception and some of us might not be, is the ability to see objects in 3 dimensions, although the images that strike the retina are 2-dimensional, and it allows us to judge distance, thank goodness. So really interesting experiments were done by Eleanor Gibson and Richard Walk in 1960 at Cornell University, and these were called the visual cliff experiments. This is another experiment that I believe is in the book I've mentioned before, 40 experiments that changed psychology. And it was called the visual cliff experiment, a model of a cliff with a drop-off area that was actually covered by sturdy glass. So 6 to 14-month-old infants were placed on the edge of the cliff and coaxed by their mothers to crawl out onto the glass. Most infants refused to do so, which indicated they probably could perceive depth. So, what came into question is that something that's one of those innate things, more part of our nature, rather than our nurture. So it was some really interesting research that showed that, wow, at these really early ages, and maybe potentially not having ever experienced something like this, that these infants were perceiving depth. So what are binocular cues, and how do they help us judge depth? Well, binocular clues are depth cues, such as retinal disparity and convergence, that depend on the use of our two eyes. As an object becomes closer or farther, that should say farther, not father, both binocular depth cues operate to help us judge distance. So they operate together. So try this. Hold your two index fingers about 5 inches in front of your eyes, with their tips ½ inch apart. Now look beyond them and note the weird result. I'll give you a second. Okay, so how does retinal disparity work? By comparing retinal images from the two eyes, the brain computes distance. The greater the disparity or difference between the two images, the closer the object. So what is convergence? Convergence is the inward angle of the eyes focusing on a near object. Here's another thing to try. Hold your textbook or some other written material out at arm's length and focus on the words on the page while maintaining your focus, and you might have to blink. I'm someone who blinks an awful lot. Slowly bring the book closer and closer to your eyes. I think it's because I have contacts. Do you feel like a little bit of a tightening around your eyes? As the 4 muscles around your eyes work to move the eye to focus, they send signals to the brain that the object in front of you is getting closer. That is convergence. So what would you answer? Narmeen is viewing the board in the classroom. She knows that the board is located far away because the view from her left eye is slightly different from the view from the right eye. Her ability to judge the distance of the board is due to which depth cue? Sorry about that. I had some technical issues and lost and had to actually log out and log back in. So for this one, the answer is A, retinal disparity. So what are monocular cues and how do they help us judge depth? How do we judge whether a person is 10 or 100 meters away? Really important to understand. Retinal disparity won't help us here because there won't be much difference between the images cast on our right and left retina. So we need to use something called monocular cues, which are depth cues available to each eye separately. And they're really fascinating if we think about them. What is relative height? So we perceive objects higher in our field of vision as farther away. Because we assume the lower part of the figure ground illustration is closer, we perceive it as the figure. So invert this illustration and the black will become ground like a night sky. So if you turned it upside down. So what is relative size? If we assume 2 objects are similar in size, most people perceive the one that casts the smaller retinal image as farther away. So this comic on the right is comical. I have no depth perception. Is there a cop standing on the corner, or do you have a tiny person in your hair? Now, most of us hopefully understand, like, when we're sitting there talking to someone, that people that are farther away are going to be a lot smaller. Or if you've been on an airplane, you see that things that are farther away are smaller, and you know that they're smaller because they're farther away. What is interposition? If one object partially blocks our view of another, we perceive it as closer, like as in this picture of the deer. The deer blocked the tree trunk, so the tree trunk seems farther away. So what about relative motion? As we move, objects that are actually stable may appear to move. You may have noticed this in a car before. can make you feel a little out of sorts. If while riding on a bus, you fix your gaze on some point, like house, like right there, the object beyond the fixation point will appear to move with you. Objects in front of the point will appear to go backwards. The farther an object is from the fixation point, the faster it will seem to move when it's actually not moving. How about linear perspective? I've always thought it was so interesting about how we can draw things that, like these two pictures. I'm not an artist at all, but I remember taking art class in 7th grade and learning about perspective and drawing this kind of thing. And I thought it was so fascinating that this is how we can use this concept of linear perspective to make things seem either farther or closer away. So parallel lines appear to meet in the distance. So the sharper the angle of convergence, the greater the perceived distance. How does the brain perceive depth using linear perspective cues? So the yellow sign in the car, which are farther away from where the two parallel lines of the road seem to come together, are perceived as closer. So the car in this image is closer to where the parallel lines are coming together, so our brain is thinking it's farther away. When actually none of those things are actually in that picture, right? That's just not even a three-dimensional image, but that's what our brain is perceiving. How about light and shadow? Shading produces this sense of depth consistent with our assumption that light comes from above. And some of you that might be artists might be really familiar with these things. In the inverted view, the hollow will become a hill. So the illustrations in the previous slides give you like this opportunity to practice identifying monocular depth cues, and it might even be really interesting for you to practice drawing some of them if you have some art supplies, so you could really understand and identify and even label what the different monocular depth cues are. Look for some cues. Look for them in drawings and photographs in real life. Look for examples of them so you become more familiar with them. Keep learning it and practicing it. There are almost always cues to identify, and often more than one monocular cue will be present in an image. Keep practicing this will really help you master these terms. Practicing and identifying them will really help you master them if they end up being on the AP exam. So what is stroboscopic movement in the phi phenomenon? So our brain perceives a rapid series of slightly varying images as continuous movement, which is called stroboscopic movement. We construct that motion in our heads, just as we construct movement in blinking marquees and holiday lights. The movement isn't actually there. It's just our perception. We perceive two adjacent stationary lights blinking on and off in quick succession as one single light moving back and forth. Lighted signs exploit this phi phenomenon with a succession of lights that creates the impressions of, something like a moving. So what is perceptual constancy? So think about top-down processing versus bottom-up processing we talked about in a previous module. So perceptual constancy is a top-down process that recognizes objects without being deceived by changes in their color, brightness, shape, or size. Regardless of the angle of viewing, the distance, the illumination, we can identify people and objects quite quickly. It's rather amazing. Even if the image on our retina seems changing, our brain can keep it constant. So what about color constancy? Perceiving familiar objects as having consistent color, even if changing illumination alters their wavelengths reflected by the object, as you can see in this picture to the right. How about brightness constancy? What is that? We perceive an object as having constant brightness, even as its illumination varies. This perception of constancy depends on relative luminance, which is the amount of light an object reflects relative to its surrounding. So from this picture, you can see an example of this. So what would you answer for this one? Even though a banana might seem to be changing color as lighting in the room changed, Jane knew that the color of the banana was not actually changing. What was this due to? As we just mentioned in a previous slide, that would be C, color constancy. So what about shape constancy? We perceive an object as having an unchanging shape, even while our distance from it varies. Size constancy, we perceive an object as having an unchanging size, even while our distance from it varies. So we assume a car is large enough to carry people, even when we see its tiny image from 2 blocks away. Like, think about it. You're standing on a corner waiting for a car to come, and it looks really tiny, but you recognize that it's big enough for you to fit in with maybe some of your friends, right? So to our eyes, it appears an object, whether a car, a friend, moving away from us, is getting smaller. That's what our sensory system is seeing that it's smaller, but our brain is perceiving it a little bit differently. Our brain understands, based on mostly on our previous experiences, our prior knowledge, that the friends in cars don't actually shrink, right? Kind of weird if we thought that. Our brain interprets the visual input as just an increase in distance. And that's a great example of the difference between sensation and perception. So I'll pause for a quote. Sometimes I wonder, why is that Frisbee getting bigger? And then it hit me. And then it hits me. That's kind of funny. Okay. How does the Ames room alter our perceptions? Okay. And we have an example of this close to where I live in California at a cool museum. The distorted room designed by Adelbert Ames appears to have a normal rectangular shape when viewed through a peephole with one eye. The girl in the right corner appears very large because we judge her size based on the false assumption that she is the same distance away as the girl in the left corner. But as this diagram shows, the girls are actually about the same size, but the room is distorted. So it gives the perception that the girl on the right, going back to that picture again, is much, much larger, when actually she's just much, much closer. So what do we learn from research on restored vision? Fascinating stuff. A few dozen adults who were blind from birth due to cataracts later gained sight. Most of their life, they could only see diffused light. After cataract surgery, the patients could distinguish figure from ground, and they could differentiate colors, suggesting that perhaps these aspects of perception are innate, that due more to their nature rather than the environment. Is there a critical period for the development of perception? A critical period meaning, is there a specific age that you need to be able to develop that perception for it to be able to occur? So surgery on children in India reveals that those who are blind from birth can benefit from removal of cataracts. And the younger they are, the more they benefit. But their visual acuity, which is sharpness, may never be normal. For normal sensory and perceptual development, there does appear to be a critical period, again, which is an optimal period when exposure to certain environmental stimuli or experience is required for that specific component to develop appropriately. So how does sensory restriction reveal the effects of experience on perception? So researchers restricted the vision of kittens, baby kittens. After infancy, when their vision was restored, the kittens behaved much like the humans born with cataracts. They could distinguish color and brightness, but not the form of a circle from that of a square. Their eyes had not degenerated. Their retinas were still relaying that information to their visual cortex. Think about that, where that is in your brain, in the back of your brain. But the lacking early stimulation, their brain's cortical cells had not developed normal connections. So the experience matters. So what about adaptation when it comes to your perceptual system? What is perceptual adaptation? It's the ability to adjust to changed sensory input, including an artificially displaced or even inverted, upside down, visual field. So can we adapt to inverted vision? Well, this guy, researcher Hubert Dolezal, did a lot of research on this. Oops, missed, thought this researcher as he attempted a handshake while viewing the world through his inverting goggles. And if you get a chance, you should try out some inverting goggles. They're fascinating. Yet, believe it or not, kittens, monkeys, and even humans can adapt to an inverted world. After he wore his inverted goggles for a long enough period, he was able to adapt and function more like normal than you would really imagine. Even though his sensory system was seeing things upside down, his brain started perceiving it in the right way. So let's review our learning targets. Describe the Gestalt psychologist's understanding of perceptual organization. So they searched for remember, the Gestalt is all about the whole. They searched for rules by which the brain organizes the small parts, the fragments of sensory data into these wholes, these Gestalts, and pointing out that the whole may exceed the sum of its parts. And whenever you're hearing about Gestalt, you should be thinking that the idea is the whole is more than the sum of its parts. So the Gestalt psychologists noted that we filter sensory information and we construct our perceptions. How about the concept of figure, ground, and grouping? How do they contribute to our perceptions? To recognize an object, we must first perceive it as a figure, as distinct from its background, its ground, the surroundings. We bring order and form to stimuli by organizing it into meaningful groups. Think about those 6 lines we saw, but really we were seeing them as 3 separate groups because of grouping. How do we use binocular and monocular cues to perceive the world in 3 dimensions? Well, in terms of depth perception, we see objects in 3 dimensions and judge distance. The visual clef experiment and other research since then has demonstrated that many species naturally perceive the world in 3 dimensions, either very soon or right at birth. So binocular cues such as retinal disparity use information from both eyes, whereas monocular cues use information from only one eye. And finally, how do we perceive motion? Oh, actually, we have one more after this. How do we perceive motion? As objects move, we assume that shrinking objects are retreating and enlarging objects are approaching. We can think about that really easily in examples. A quick succession of images on the retina can create an illusion of movement, as in stroboscopic movement and in the phi phenomenon. So we should be able to explain how perceptual constancies help us construct meaningful perceptions. Perceptual constancy, actually we have a few more of these, sorry. Perceptual constancy enables us to perceive objects as stable despite the changing image they cast on our retinas. Whereas color constancy is our ability to perceive constant color even though the lighting or wavelengths may shift. Brightness constancy is our ability to perceive an object as having a constant lightness even when it's illuminated. How are perceptual constancies, how do they help us construct meaningful perceptions? And again, remember, all of this that we're learning, we should be thinking about how what's coming in through our senses isn't necessarily what we're perceiving because we are constructing, our brain is constructing meaningful perceptions. Shape constancy is our ability to perceive familiar objects, such as an opening door, as unchanging in a shape or a silhouette. Size constancy is perceiving objects as unchanging in size or dimension, despite their changing retinal images in our eyes. Knowing an object's size gives us clues to its distance, right? If something's smaller, it appears farther away. But we sometimes misread monocular cues and reach the wrong conclusions. So describe what research on restored vision, sensory restriction, and perceptual adaptation have revealed to us. So people blind from birth who gained sight after surgery lack the experience to visually recognize shapes and forms. Sensory restriction research shows there is likely a critical period for some aspects of sensory and perceptual development. People given glasses that shift the world, those inversion goggles, experience perceptual adaptation. That is, they are initially disoriented, but over time they manage to adapt to their new context. Really fascinating stuff. All right, thank you guys for listening. Sorry I had a few different technical issues. Hopefully it didn't make it too difficult to listen. Thanks again. Take care.